Okay, we'll go ahead and get started. So welcome everybody. Um, I guess it's good morning, good evening, good afternoon, good middle of the night, depending on where you are. I'm actually in Redmond, so I'm about 10, 15 miles from where Jeff is, and happy to be presenting. I wish we could be doing it live, but I want to thank Carl and Peter for setting this up. So what we're going to talk about today is effectively temporal tables in SQL Server, not to be confused with temporary tables in SQL Server. And this is going to be a shorter version of what I did at the Portland conference last year. I'm going to keep it pretty high level, but I think you should be able to see kind of what's going on, and hopefully this will encourage you to try it on your own. So normally I would tell you a little bit about myself, but I've asked Peter to set up a survey, and I'm going to paste the link. Peter just did it.
I just pasted the link.
Okay.
So
well,
please
click on one of those
fill in.
links. And while I give a little introduction here, if you guys could go quickly take the survey, I'm kind of curious as to what percentage of people are using SQL Server at some level or not. I know that there was one comment I saw yesterday that somebody was working for a company that doesn't allow SQL backends or anything like that. So it has to be an access. So the hope is we'll get a little quick time. So take the survey. A little bit about me. I've been developing with Access since 1.0. I would call that developing in air quotes because I didn't know what I was doing for the first several months. But I stuck with it, and by 1.1 I was making a living. I started using SQL Server with a beta version of Access 2.0. Did that for a lot of years. I ran a small consulting firm in Colorado for I think 15, 16 years. And then in 2008, I guess I had my first midlife crisis. And instead of getting a sports car or a younger girlfriend, I ended up getting a job as a test engineer with Microsoft. And so Jeff and I worked together for, I guess, 6 years while I was there. I've been fortunate enough to present at events all over the world. I'm currently back consulting. This time we're trying to migrate applications, whether there's Access or SQL backends, to the web. And then we will, basically move to Azure, and then we will build a .NET Core MVC project on top of it to expose whatever needs to be online. And then from a personal note, I enjoy playing baseball and traveling the world, looking for a place to semi-retire, preferably with good beer. And I guess the other thing I should say is don't feel bad about the midlife crisis, because I had another one, and I got the sports car and the younger girlfriend. So it all really kind of worked out for me. Okay, couple other, I guess, plugs is I've got a couple add-ins that you can download. One is a replacement for the Link Table Manager, and then one I'm going to be demoing in about 3 hours from now. So if you haven't taken the query or the, I guess, survey, I'm going to paste it in once more so you can see it. Please do so, because we're going to switch back over to Peter in about 30 seconds to look at the results. Now, I will share one kind of interesting story. It's kind of timely in the light of recent events. So for those of you who, I guess most everybody knows that Seattle was the first hotspot in the US for the coronavirus. We had a long planned trip to go to Portugal last month, and at the time, Portugal looked much safer than the US. So we decided to go ahead and go. About halfway to Amsterdam, we learned of the pending travel ban. And so we landed, were able to change our tickets, and we took the exact same plane back to Seattle. But we had about 30 minutes before boarding, so we had 2 very expensive Heinekens and flew back. Now, I'm a fan of beer. There aren't too many beers worth flying 19 hours for, and I'm pretty sure Heineken isn't one of them. So anyways, Peter, can you bring up the results? I don't know that I can see them. Let me just take the survey. No. So if I can toggle back over to Peter.
Do you see?
Yes. Okay. So the vast majority of you use it sometimes, a few rarely, and a few nevers. Okay. And that's obviously updating. Great. So thank you for those that took the response. For those that you have never used it, hopefully this will give you a little bit of impetus to go check it out. For the others that can't, well, I guess maybe you can talk to your management about this. So enough of the introductions and survey stuff. Let's jump into what we're going to talk about. The who, what, and when. Well, this is basically tracking which user changed a record, what they changed, and when. So for the who part, pretty straightforward. It's going to be the user or maybe a process that changed the data. And it's nice to have this because you can help identify kind of those malicious users or people that need training. The what is the data that changed. And in most cases, and in the case of the temporal tables, we're going to log the entire row that has changed. I have seen some systems that will log just the fields. And while that can save storage space, it seems like a lot of extra work to get something meaningful out of it. And if you think about it today, storage is way cheaper than it was 10 or 15 years ago. And then the when is the time the record was edited and deleted. And I would recommend using the server time in UTC just because you have more flexibility with that, especially if you're in Azure and you can have people coming in from all over. So why do we want to track the record history? Well, hopefully this is pretty self-explanatory, but there are things like auditing, regulatory compliance, and data forensic, which you can use as a way to kind of prove that you're doing your due diligence. It also allows you to do historical looking back and reapply things. So if a set of records got changed mistakenly over time, you can kind of undo those by seeing what the changes were. It'll also help you analyze data trends, so you can see which tables are getting edited more often or what records are getting edited more often. Hopefully you never have to deal with this, but if you end up with a low-level data corruption, this is maybe one more tool that'll help you rebuild the table. And then I think one of the things that you may not be aware of is with the temporal tables, as the name sort of suggests, you can actually do point-in-time reporting, which is a huge win for doing this. So if I was live, I would ask this question. I'm guessing most everybody here has had to implement some kind of change tracking at some level. If not, wait, I'm sure you will. And for those of you who have done this, it's largely a pain in the backside. There hasn't been any real good way to do this until now. So how would we have done this in the past? Well, with an MDB file, there's no way to enforce it at the table level. So what you have to do is add the logic on every single form, which is obviously a hole because you want to have your split back end and front end. So you can't really ever enforce it if somebody sneaks into the back end or runs a query or something like that. And then it has the added burden of having to keep your table, your history table, and the code all in sync whenever you make a schema change. As for getting the who piece, MDB files had the user level security, which wasn't all that secure, but you could sort of make it work. You could also use Windows login, or you could roll your own, which I would strongly recommend against. It's pretty trivial to crack those. All right, fast forwarding to the ACCDB file format, we introduced in 2010 data macros, which this actually allows you to enforce it at the table level. It's obviously not as scalable as something like SQL Server, and I will admit I haven't done this implementation for more than just a handful of users, so I don't know how well it scales if you get past 10 or 15 users at a time. It has the same drawbacks of having to keep your table, your history table, and your data macro all in sync. Also, user level security was deprecated in ACCDB file format, so you're kind of left to the Windows login or some integrated Active Directory or rolling your own. Now, I have some sample files that if you're in that ACCDB file format and kind of stuck there, a little bit of VBA code that'll actually script out all the macros you need to implement some basic auditing. Obviously, anytime you make a change, you're still going to have to go manually update those, but this can kind of kickstart what you're doing. All right, and then SQL Server triggers, they've been in SQL as long as I can remember. You can enforce them at the table level, which is great. And obviously, it's SQL Server. It is way more scalable than an ACCDB file format, so this will work for hundreds or thousands of users. Unfortunately, triggers are hidden and really kind of easily to forget about. And I don't know, it's just my perception, but over the last 10 or 12 years, it seems like triggers have really kind of fallen out of favor. I've seen countless stories about somebody chasing their tail on a problem only to realize a few hours or a few days later that there was a trigger they didn't know about. And again, like the other solutions, it has the issue of having to keep everything in sync. Now for the who, you really have to have it coming from SQL Server, so it has to be the Active Directory SQL login or something SQL knows about. I know some people will use kind of a generic login for their users. This kind of goes by the wayside because you'd have people lumped into groups with permissions, not individuals. I'm not going to go into these largely because I've never used them, but when I was first looking at temporal tables a year and a half or so ago, I ran across something called change data capture and change tracking, which if you're stuck in a position where you've got maybe SQL 2000, hopefully not 8, but maybe 12 or whatever comes between that and 16, this might be something to look at. So, temporal tables. They were introduced in SQL Server 2016. They're actually introduced as the ANSI SQL 2011 standard. So you'll see temporal tables implemented across MySQL and other things that adhere to the ANSI standard. SQL Server, or Microsoft, I should say, implemented them in SQL Server as system versioned. So that is kind of the brand name. So you could think temporal tables is the Coke and temporal tables is the cola, system version is the Coke or the Pepsi. So I may use those interchangeably, but temporal tables and system version tables are effectively the same thing. It has the advantage of being enforced at the table level. And then the huge advantage here is there's really nothing to maintain. And once you become familiar with this, this is literally something you can implement in a database in just an afternoon. And we get the added advantage of having this time travel. So there are a few requirements with temporary tables. The first is your table must have a primary key, which hopefully everybody's using a primary key so you can edit it and access. You also have to have 2 time period columns, which are going to be defined as a date time to data type. And we'll see an example of that in just a second. And then the history table must live in the same database. So you can't split it off into a separate database. It can, however, be in a different schema, which is probably a best practice. Now, there are a few things that tables can't have. Hopefully you won't ever run into this. But if you've got a delete or an update cascade, if it's part of a foreign key relationship or an instead of trigger, these things could kind of circumvent the internal workings of the temporal table, so you can't have them. And then as far as the history table goes, it can't have any constraints. So no foreign keys, primary keys, defaults, etc., things like that. Now this makes sense because let's say I have a customer table and I make a couple edits to a customer record over time. That ID is going to show up multiple times. So while it might be a primary key in your main table, it's going to be repeated. So the history table is effectively going to be a read-only snapshot. A few cautions about this. Temporal tables support the large data types. So if you are implementing this thing on a table and one field changes and there's another big blob of data that doesn't change, this is going to increase storage, which again is cheap, but it may have some performance issues. So you might want to redesign your table structure to kind of minimize the bloat if you have a lot of those. And then there's a possible bug that was reported by Access MVP Tom Van Stivout. We worked together on it, tried to figure out what it was. I wasn't seeing it Azure. I tried it on-prem, couldn't seem to get it to work. We tried different drivers. We think we narrowed it down to the implementation of temporal tables in the sample worldwide importers database. So if you're tinkering with it there, be forewarned, it may not let you add or delete records. Okay, so that's enough of kind of the overview. On to kind of the heart of things, the what and the when. So to handle the what, all we have to do is turn on system versioning, and SQL Server will do everything else for us. The when, in order to do that, you have to have the two date time fields we talked about. So without further ado, let me see if I can toggle over to SQL Server. Now I have created a very simple test table here. Oops, let me look at this one. And you can see it's basically got an ID, a first name, last name, and a row version, so we can edit it with Access. If I go in here and edit the table, you can see it's completely empty right now. So what we're going to do is first add the date fields. And so I need to define these two fields that are both date time 2. I've chosen to call it valid from UTC and valid to UTC. You can name those whatever you want. And then we need to set the default. So the from is going to be the current UTC date time. And then for the end period, I'm going to set it to 1/100th of a second before New Year's on the year 10,000. Which is probably far enough out in the future that it's not going to impact your grandkids, grandkids 12 times removed. Now, because I can define these names however I want, I have to tell SQL Server what fields are going to be the time fields. So for that, I say period for system time, and then I put in those same names, which is going to be the from, which is going to be the to. So let's go ahead and run this. And that's it. Command completed successfully. So now if I go look at this table, you can see it added the valid to and from. So that's the first piece. The second piece is we need to turn on the system versioning. And to do that, I simply run an alter table and I set the system versioning flag to on. And that will enable system versioning. I would strongly recommend that you define your history table name. This is optional. If you leave it off, SQL Server is going to create effectively kind of a random name for you, which isn't going to probably help you in the long run. So in this case, I've chosen just to call it the same thing as the table, but I've appended history. So let's run this. Command completed successfully. Now I'm going to go ahead and refresh over here. Refresh. And now you can see that test table is system versioned. And if I try to edit it, you'll notice that I can't edit it from here anymore, which we'll talk about later. But you do lose some functionality that you may be used to. Let me switch over to Access now. So what we're going to do is we're going to actually look at these tables in Access. So to link those tables, I'm going to quickly go in here, and I'm going to add those new tables. And then there they are. So you can see here's our test table. Now you may have noticed that I had set a hidden flag in SQL so they don't show up in the default views. Access doesn't know anything about that. And then here is the history version, right? So they're the exact same tables. So I'm going to go ahead and enter a little bit of that. We can, let's see, expand out these just so you can see a little bit more. So you can see there it defaulted to the times and the valid 2 is way out in the future. If I look at the history table, nothing's in there yet because I haven't made any edits. I've only added a record, so we know exactly what the record looks like. So I'm going to go ahead and make a few more changes here, and I'm going to move off the record each time so I can edit it. Don Bauer, I think. So now let's look at the history table. And lo and behold, I have records in there. And you can actually see kind of the trend of how things were edited. Let me, oops, I don't want to drag. I want to make those both bigger. Mouse fail. And you can see now the UTC time shows the end date, which you can see they kind of logically daisy chain. This value gets put here, gets updated, gets put there, so it always toggles through. So that, in about 5 minutes, is how you can turn on system versioning. Now, I talked that there was nothing to maintain. And let me just toggle back over to here. Let's say we want to go ahead and add a new field. So I'm going to run another script that's basically going to add a new field to this. So if I run this, bingo. Now if I go look, you can see the system version table shows up here. If I look at the columns in it, it actually added new field here, even though I ran the script to add the column here. So SQL Server, when it's system versioned, will keep your design changes in sync for you. Let's jump back over here, just so you can see. Actually, I probably should have saved the changes. Now I need to refresh those so that the schema change will show up, but now you can see the new field is there. And if I go to this field and say, hello, DevCon 2020, those record changes, like before, show up here. Oh, and I didn't save the last one. There. So when you add a new field, even if it has a default, it's going to be empty. And as you change it, it works just magically. Now, should you ever want to delete a field, you need to be forewarned that what will happen if I delete this field is the history field gets deleted as well. So kind of make sure you know about that. Okay, just kind of recapping a bit. So here's the script. I'm not going to go through it, but put it in the slide deck just so you can kind of see what it is. So you run those two statements, and basically it'll turn on the system versioning for you. Now, a word about logical deletes, and it goes by several different names, but what I determine as a logical delete is using a bit field or a date time field to show when a record was deleting it or deleted, but you physically don't delete the record. So you need to be sure to filter that out. With temporal tables, I'm not sure you need that anymore. I've kind of been on the fence and I haven't had a good project to kind of implement it on. But one time I was actually bitten by not filtering out a deleted record. Client asked me to whip up a report quick, so I did. It turns out I used the table and not the view that filtered things out when I did this. The end result is they ended up making some decisions based on data that was deleted, which didn't make them very happy. So something to kind of look at is maybe you don't really need those logical deletes. Um, Now, so that's got the what and the when. What about the who? Well, there's nothing that's baked in to make it as simple to do as we talked about with the date pieces. So you have to be a little creative, and I wish I could take claim for this, but it's something I found online. You basically add two fields. You add a created by field that's going to default to the system user, and then add a modified field, which is going to be a calculated field that defaults to the exact same thing. So with that, let me jump back over to SQL Server. And here is a script that's going to add those fields to it. So that it'll add a created by, which is going to default to the username, and a modified by, which is a calculated column that'll do the same thing. So let's go ahead and run this. And what you see is I get an error message saying that the system version table can't be modified because a computed column can't be added while system versioning is on. So what I would have to do is turn off the system versioning, add both columns to the table and to the history table, then turn on the system versioning and keep my fingers crossed that it worked. So we're not going to do that. We're actually going to go delete the table and just start over. That's the delete field. So here I have to first run the system versioning. If I don't, it's going to say I can't drop those tables. So if I run them all in one hit, command completed successfully. Now I'm going to go ahead and run the create script. And if we refresh, we're back to having an empty table that is not system versioned. So I strongly recommend that when you do this, you add everything at one time. It's just going to save you a lot of headache and hassle. There may be times you have to add a calculated column after the fact, and in that case, you're going to have to jump through some hoops. But basically, I'm going to do the same thing. Add those date time fields, add the modified fields, add the system for period, and then turn on the system versioning. Now, this gets repetitive, and you probably want to do this over and over on multiple tables. So I would recommend running a script, and I will give you a copy of this in the download. But basically, it's going to run that same SQL syntax, but I'm going to pass in a table name. So I can generate all these things, and you can change these to be whatever you want to call your fields. So let's go ahead. I'm just going to run the script here because I've tested with this, and I know if I select everything, it'll work. So now if we go back to here and do a refresh and look at the columns, you can see I've got the valid to and from, a created by, and a modified by as well. So let's go back over to Access so we can kind of see this in action. We'll say yes. Let me refresh once more. And now again, remember those tables are empty. But if I go in here, whoops, I have to add a can't do that. You can see these are all changing over here. But unfortunately, I'm the same user, so it's going to look the same here. Let me do another edit. It's going to look the same here as the history table here. So take my word for it, and you'll actually see when I show you how we query this, you'll see a case where the modified where it syncs up more. Okay, so for the who piece, basically you want to run this alter table by adding those two fields. And as I pointed out, you want to really add both of them at the same time when you figure out what you're going to do. I will include the script. There's a former Access MVP, Klaus Oberdohoff, so I know he was on this call, and I apologize, I probably didn't pronounce your name very well. He actually has some much more advanced scripts you can run, and here's a link to the OneDrive where you can actually download those. Now, if you've never used SQL Server logins from Access, it's pretty simple. Basically, what I would recommend is not storing the SQL passwords in Access. If you have a linked table and you say save passwords, it'll store them in plain text, which makes them very easy for someone to get. I tend to use a DNS-less connection for everything. I think it's just the most flexible. You don't have to worry about having a DSN set up on there. So the trick from this is when you create the connection, don't include a username or password. So leave those blank. And then when Access first opens up the table or view, you're going to see a fairly ugly dialog box prompt up that you're not really sure if it's coming from Access or from SQL. It's going to prompt you for a username. Not going to remember anything. It's just this generic kind of dialogue. What happens when you supply the username and password is Access is going to go ahead and cache that. So anytime you open another connection with the same server or database, it's going to try to reuse that cached connection. Now, the trick that I like to use is creating a form where I prompt the user for their username and a password. When they hit log on or OK, I create a temporary query def where I take the connection string of a table, I append their username and password, I open a record set, then immediately close it, and if it's successful, it kind of primes the pump so the connections are there. So it's a much better experience, and there's a blog post on the Access blog written by another former Access MVP, Ben Clothier, which will detail this in way more detail. Now, if you've never used the roles in SQL, it's pretty simple, and I'm just going to give you kind of a high-level overview here. Basically, in the master database, you need to create a login for each user. And if you're using SQL Azure, you really have to script this. So you would do a script like create login username with password. Boom. Then in the application database, you have to use a couple things. First, you need to create a user, and I tend to use the same login name as the user, just so there's no confusion. And then I need to add them to whatever roles. So if you run scripts like this, and there's more detail here, this will basically turn on the ability for users to know which user it is, so that the when gives you something, or sorry, the who gives you something meaningful. Okay, so temporal tables sound great, but I want to point out a few drawbacks. I don't think they're huge. The first, you may have noticed, I was scripting all the changes, and that wasn't just to keep the demo gods happy. That was actually required. Once you turn on system versioning, you lose design view. So you have to script things. It's pretty simple to do. You saw I was running commands like this that just says alter table name, add the field and the type, and that's it. Now, it really is probably a good idea to script your changes anyways. You should all hopefully have a test in a production environment. So as you're making a schema change, you're going to want to test it to make sure you didn't mess something up. And then you want to apply those changes once you're happy with them to the database. So scripting is kind of a good thing. If you're using Azure, you'll also find that scripting is 10 times faster than opening a designer. At least that's my experience. And as I kind of alluded to, when you turn on system versioning, you can kind of lose some functionality. Now, what I see with SQL Express, which is what I'm demoing on, when I right-click on that, it actually loses all the properties. Whereas on Azure, I can still query the first 1,000 records or edit the first 200 records. So be forewarned, depending on your environment, you may see different things. And then kind of a more on the minor side of things, your history tables are going to show up in the SQL Management Studio design view. So if you're creating a view and you say select the tables and you've got all these history tables in there, it's going to just kind of clutter things up. And then along the lines with views, temporal query syntax, which we're going to look at in just a second, won't render in the diagram pane. So if you're using the views to kind of, or the view designer to create your views or queries, that won't work when you get into the system versioning. To turn it off, very simple. Just run the system versioning off, and I did that real quick when I deleted the table. And what that does is it removes the system versioning and makes your history table a regular table again. It doesn't delete the history table. So this is how you can turn it back on. You have to manually re-enable the system versioning. Okay, that's great. That's how you implement it. So what about the querying? We talked that there's ways to query your data. Now the good news is on your standard kind of main table, the select you do today is going to work. It's just going to return the current record. So really there's no change what you have today. You can also query the history table because it's just another table, and that will return all the history records that you have filtered for. But there's a couple new things you can do. Whoops, wrong button. This is the temporal queries, and this allows for the historical time travel. So if you have the data, you can go back and look at it. There's still no way to look forward, which I would imagine won't happen in our lifetimes. But what they've implemented is a new clause, and it is for system time. And then you can have one of 5 options. Some of them take arguments, some don't. There's all, as of, which takes a date and time, from, to, between, and contains in, all take a start and an end date time. So we'll look at these to see what they kind of return, and then we'll see some examples. Okay, so the for system time, basically all, so if I say for system time all, it's going to return all the rows in the temporary table and all the rows in the history table. So this is effectively a union query. As of returns the valid rows for a point in time. So if I say system time as of, December 31st, 2019, it'll show me how things looked in that table on New Year's Eve. Now the from and the between act very, very similar. It's going to return rows in both tables. The subtle difference is the from excludes the current end date and the between includes it. And that end date has to match up to the exact fraction of a second. And then finally, the contained in. This is only going to return rows in a table that are in the date range. So it's going to only take things out of the history table. With that, let's flip back over to SQL, and we can do this all in SQL. Now, you may have noticed I have another table here called employees, and this is one I kind of cooked up. And if I run a select query on here, you can see I have 4 employees. We can see the modified date is using that same modified because I'm logged on with just Windows security to SQL. If I select the employees table, or sorry, the history table, you can see I have like a dozen change records here. And here's a case where the modified, you can see, depending on the user I used, shows a different value. It never shows the user, which is my current user. So that's what our data looks like. So let's first look at the all. And for the all, I'm going to select just the records for my person. And as you can see, it returned, 8 records. Now, as you look at this, even though the records were obviously edited in a meaningful way, they don't order that way. I wasn't a senior developer and then went to developer 2 and then mailroom clerk to nothing to CTO, and my salary didn't fluctuate. So the point here is you have to explicitly order your records to get something meaningful. So not a big deal. If I run that again, this time I say show me the most current record at the top. Now you can see there's kind of a logical progression of how the records went through. And I want to call it, if you look over here, look at the modified here. This record here is actually the current record. So I get this modified date, which is the current user, which is kind of meaningless because I haven't modified anything. But if I look down here, you can see which records changed and when. So that's the all. It's, I guess, good for kind of looking at how a record changed over time. Now, this is the as of, and this is the point in time, which I think is probably the most useful of these. And I'm going to run these. They're all going to just query from the employee table at different times. So let's run all 4 of them at once. And let me expand up a little bit here. So you can see when I ran the first one, it returned no data. That's because there was nothing in that table. That table didn't actually even exist back September 1st of last year. And then as I go through these, you can see, okay, here I am as an employee. When I go a little bit further, Jack Stockton is now an employee. I actually have a title. And then as we get down here, excuse me, what you can see is I actually have 4 employees now. These 3 records are current because they show the current user. This one here is not. It's an actual history record. I'm still the senior mailroom clerk, whereas currently I'm the CTO. So that's the point in time as of, and I think that's the most useful. You can also do it with a where clause. So let's go ahead and look at Jack's record about 5 minutes apart, and we can compare those. And you can see on here, Jack didn't have a position and a salary, and then he did 5 minutes later. So I could have done this with a union query, but I wanted you to show that these are 2 separate queries that you can run to kind of compare how things changed over time. And that gives you an exact kind of snapshot. Now the between, I'm going to go ahead and run this 2 times. The difference is I'm running them about 10 seconds apart. So if I run that, you can see this one returns 2 records for Jack, because remember, this is returning history and current record. And this one here returns 3 records because this record here was edited just a little bit after the other record. So that's the between. Now the from, like I said, looks exactly the same, and I think the best way to illustrate this is to run 2 queries, and I've got the exact same dates going in from the beginning and the ending. But notice here, I've had to drill down to the actual 100th of a second. So it's going to run the same query up here for the between. Let's run that. And you can see here, because that last record matches exactly to that date, I get the extra record here, whereas in the from, it gets excluded. And then the last one is the contained in. So I'm going to run an all for Jack just so you can see all the records, and then I'm going to run the contained in, and I'll order both of them by the valid UTC. And you can see there's 4 records that I have for Jack. But here, because I've set in the time frame here, I only get the 2 records here. And notice that this date is out past where the data, edits changed, but it excludes the current record, which is where the valid from would be, and so it doesn't show up. So this is only looking at the history table. So I know that's a quick whirlwind. I'm going to jump back to the slide deck and we'll finish up here. Just a couple words about querying tables, multiple tables, which obviously we do most all the time. So if you have temporal queries with more than one table, you have to have a system time on each table. So this is kind of stunt SQL, but it would look something like this, where you have a select from table A with a system time, and then I'm doing a left join on table B with the same system time, and then they're joining on the primary and foreign keys. This can be dangerous if you end up having 2 different date ranges. You could get really goofy things. I don't think it'll open up a wormhole, but it could. So you really have to be careful when you're doing this. Now, fortunately, there's a very easy way to fix this. Create a view and apply it once. So by creating the view and then adding the system time as of, SQL Server will take care of everything for you. So I would strongly recommend, in most cases, you want to go ahead and create the view to handle that. And with that, I think I've got about 5 minutes for questions. So I'll open it up. I have not been able to keep up with the chat, so I'm going to start looking at the chat.
So the only real question left over, I think, is can you discuss potential performance penalties for implementing temporal tables?
I can. So I actually haven't seen anything. Of course, everything I've done with this has been on SQL Azure. So it's, and really the main client I've worked on this is on the East Coast. They're based in New York. And so I set up a tenant for them in a data center on the East 2. And so the performance for me, I notice a lot of lagging. It's fine for them, but I'm in Seattle on the other side of the country. But near as I can tell, it handles it pretty gracefully. And that was on, I think we're just using the lowest instance of the SQL Azure, so the one that costs, $5 or $6 or euros. So I see there's a few other questions. Nope. So the question from Hannah, do temporal tables need versioning? Sorry, do all the tables need versioning if you query multiple tables? Nope. It'll figure out just the ones that need it. And you don't have to apply temporal tables to your entire database. You can apply them just to the ones that you need. And then Phil has a question. Can the simplified table change like certain fields? No. As far as I know, when you turn this on, it's going to do everything for you. At least that's what I've always done. There may be a way to explicitly say exclude these fields. So something to dig into.
So I think we're done and time's good.
Okay, good. Yep. Well, thank you, everybody.
Thank you
I hope it's hard to not get any kind of user feedback during a session, but hopefully, like I said, hopefully you can kind of say, oh, that looks cool, and you'll take some time to spend an afternoon looking at it.
Yeah, you have some applause in the chat. Thank you very much.
It looks really cool.
Thank you. And thanks again for you guys setting this up. It's been great.